Hi, welcome to math-for-all-grades.com videos. In this video, I am going to show you a technique for solving in questions on large exponential numbers. Let us consider this. Suppose we have two large exponential numbers like this. 300 raised to power 900. And we have another large exponential number 900 raised to power 300. Now what is the method to compare these two large exponential numbers? Which of these two exponential numbers is greater? So look at this. Suppose we have x cube is equal to 8. If you know, then x will be equal to 2. Suppose x cube is equal to 27, or say p cube, p raised to power 3 is 27. Then what is the value of p, the base? It will be 3. Now if I ask you, what exactly is the method you are going to apply for finding x value from x cube is 8, and how do you find p value from p cube is equal to 27? The answer to this is the method of finding x and p from x cube is equal to 8 and p cube is equal to 27 is applying cube root on both sides. Applying cube root on both sides is the technique that is applied to evaluate the variables x and p. This is how it looks like. If x cube is equal to 8, to evaluate x, to find x, what you are going to do is raise both sides to a common root. Raise both sides to a common root, and that is 1 by 3. How do we know that 1 by 3 is the common root that has to be applied on both the sides? Because you have a cube here. So we want the power, the number in this powers place to become 1. For that 3 must go away. So for 3 to go away, raise both sides or raise this side to power 1 by 3. Similarly, raise 8 to power 1 by 3. Now 3 into 1 by 3. If you remember, a power n raised to n is equal to a power m into n. If you are not familiar with the rules of exponents, then do kindly watch our videos on exponents that will enable you to appreciate this formula better. So raise both sides to power 1 by 3. So 3x power 3 into 1 by 3 is equal to 3 and 3 will be gone. So 1 will be left in the left hand side. Similarly, 8 you express it as 2 cube. So 8 raised to power 1 by 3 will be 2 cube raised to power 1 by 3. 2 cube raised to power 1 by 3 is equal to 2 power 3 into 1 by 3. After they are gone, you will be left with 1 in the powers place. So this is equal to 2. In this way, x power 1 is equal to 2 power 1. That is, x is equal to 2. So the method of finding the variable x or p when you have x cube is equal to 8 or p cube is equal to 27 is getting rid of this cube, the power 3, number 3 in the powers place, by raising both sides of the equation to power 1 by 3. 27 can be seen as 3 raised to power 3. So get rid of 3 from both the places by raising them to a common root 1 by 3. So 3 into 1 by 3 is p. 3 into 1 by 3. 3 into 1 by 3 in the powers place it will become 1. 3 into 1 by 3 in the powers place here also will convert into 1. So p is equal to 3. So far what I have dealt is I have shown you the method of evaluating the variable x and p values by raising both sides to a common power, namely 1 by 3 in this context. So here also, to compare these two numbers, these large exponentials, let us raise these two large exponentials to a common root. Which will be that root? It will be whichever is the smaller power. I mean, you should raise both the exponentials to power 1 by 300 so that the smaller power 300 will be disappearing. So raise both sides to a common root 1 by 300. So here 3 into 1 by 300 from this exponent law will reduce to 900 power 1. That is simply 900. And here you will be left with 300 in the powers place. 900 into 1 by 300 will be present. 900 into 1 by 300 is of course 3. So write 3 in the powers place. Now compare these two, 300 raised to power 3 and 900. It is quite obvious that 300 raised to power 3 is far greater than 900. If you have doubt how to still compare this is how I will tell you. 900 can be looked at as 300 into 3, whereas 300 cube is 300 multiplied with itself 3 times. So there you can see 300 cube is so much larger than 900. So this is the method of comparing exponentials having large powers. The trick is whichever is the smaller power, that should disappear. For that, raise both sides to a common root. In the root, the denominator will be the smaller power. Using this method, I will solve another question. I have to find the least value of n such that 2 power n will be greater than 10 power 15. What is the smallest value of n such that this inequality condition will hold? What value of n will satisfy 2 power n is greater than 10 power 15? From the method discussed here, raise both sides to a common power. Now you must guess which common power that should be. And the answer is, it should be 1 by 15, because from the power here, from the exponential here, the power 15 must disappear. For that, raise both sides to power 1 by 15. So 15 into 1 by 15 will reduce to 1. So 1 will remain in the powers place, and here n into 1 by 15 will be n by 15. So the inequality that you have is now 2 power n by 15 must be greater than 10. Now think of it this way. 2 raised to what number will be greater than 10? Think of it this way for finding n value. 2 raised to what integral power will be greater than 10? Suppose we are finding here n, and that n needs to be an integer and a number like 3, 4, 5 or so on, not numbers like 3.5, 4.5, 3.7. As you know, these are not integers, these are only integers. They can be positive and negative, that is not very relevant to this context. So 2 raised to what power has to be greater than 10? Think of it this way. Is 2 power 1 greater than 10? No. Is 2 square greater than 10? Also no. 2 cube, is that greater than 10? Also no. 2 cube is 8. It is still less than 10. So 2 power n by 15, for it to be greater than 10, you will have 2 power 4 is greater than 10. 2 power 4 is what number? 16. 16 is greater than 10. That means n by 15 should reduce to 4. If n by 15 reduces to 4, then what will n be equal to? 15 into 4, 60. So it is 2 power 60 that will be greater than 10 power 15. So the least integral value of n will be 60. So this is how you can solve large exponential questions by applying the technique of what? Raising exponentials to a common root, where the root in the denominator will be either the smaller of the two powers or a number which is present on one side. Here 15 should disappear, here 300 should disappear. So here raise both sides to power 1 by 300, here raise both sides to power 1 by 15. Depending on the context, you have to think for yourself what power both sides have to be raised to get the variable values. Thank you for watching this video.